Significant figures is a difficult topic that is hard to explain in a brief amount of time, so I'm going to try my best to do it quickly. Let's take a look at these two numbers, 173,000, 173,000 with a decimal point. 173,000 without a decimal point, I'm just going to tell you right now, has 3 sig figs. With a decimal point has 6 sig figs. And why? Our range for 173,000 with a decimal point is plus or minus 0.1. This is a very broad estimate. It tells us that our range is either we have, let's say, a doubt of 1,000 units. So therefore our range could be plus or minus 1,000 because we don't have a decimal point there. So this tells us that this is a broader estimate than this. Let's say we had a scale that weighed in grams. You would call the scale for this that gave you this measurement very precise because the decimal point is included, and since the range is a very small window, that is a closer measurement to this. Therefore, we have 3 sig figs, only 1, 7, and 3, and 6 sig figs for this, because these zeros are very important, because it shows us that our range is plus or minus 0.1, rather than 174,000 or 172,000 if you add 1,000 or subtract 1,000. So let me try and break it down further. Significant figures include all numbers except for 0. Let me give you this example. C. 109, 107. Now, how many significant figures are in this? Let me zoom in a bit. Now, there is no decimal point, notice, but we do have zeros. However, we count zeros in between whole numbers significant. So this has 6 sig figs. And judging from how the examples above went, these next examples are much easier to understand. So let me give you another one. D. 0.006230. How many significant figures are in this? These are known as leading zeros, and they are not significant. Let me just put another 0 there, just to be safe. Because this can also be written as 6.230 times 10. Let's put our decimal point here. 1, 2, 3. 10 to the negative 3 places because we moved our decimal back 3 places. Since this can also be written as this, we only count 1, 2, 3, 4 sig figs. Because, again, our range is plus or minus 0.001. This 0, therefore, is also considered significant because of the range that is implied. See? Now it is, once you do practice problems, it does get much easier. One more, guys. Let's try this. 72.890. Now how about that? This has 5 sig figs. Why do I keep closing my pens? 5 sig figs. Not too hard, is it? So, why are there 5 sig figs? Well, we count whole numbers, 1, 2, 3, 4 whole numbers. That's a given. And this 0 here is what is known as a trailing 0. We count trailing zeros as significant because of our range is just like D. It's also plus or minus 0.001 right there. You see? So let me just give you one more. EF. Well, let's say similar to problem D, these are called leading zeros and they are not significant. Why? Again, because it can be written as 7.8 times 10. You move your decimal point in between the numbers 1 through 10. So 7 is between 1 through 10, so we put our decimal point there. We move this decimal point back 1, 2, 3, 4. Let me recount just to make sure. 1, 2, 3, 4. 10 to the negative 4. We count zeros that act as placeholders as insignificant. And what I mean by placeholders is that they can be represented as 10 to the negative 4. So that's all there is to it, to significant figures. So let me zoom back out just to give you a broader view of what we just talked about. So I hope this makes sense. 173,000, 3 sig figs. 173,000 with the decimal point, 6 sig figs. 109, 107, 6 sig figs. 0.006230, 4 sig figs. 72.890, 5 sig figs. And 0.00078 is, I didn't write that down, so good thing that I checked. This is 2 sig figs. 1, 2. Don't count these are placeholders. Count the zeros that come in between integer numbers, I guess you would call them, and the decimal are not significant because they're placeholders for scientific notation, or 10 times to the power n, shall we say. But however, zeros that come after whole numbers, that come after the decimal, such as this, are significant. They cannot be written in scientific notation, and they also represent a range of plus or minus 0.001 in this specific example. So I hope that made sense, and thank you for watching. Good luck.